So let's take a look at multiplying polynomials. So multiplying polynomials is pretty straightforward. Let's say I start up with something like, let's just multiply by a constant. Let's say I had 3 times x plus 5. Now you may or may not already know, but I think you probably do, that I can go ahead and I can distribute this 3 across, and I can make the 3 be multiplied by the x, and the 3 be multiplied by the 5. So I can get 3x plus 15. Pretty good? All right, now let's just, instead of it being x, or 3, I could make it x. So let's do x times x plus 5. So again, I'm just going to drag that over, ba-doop, ba-doop. So x times x is going to be x squared, and x times 5 is going to be 5x. Now, whenever you're multiplying polynomials by single terms, that's really all there is to it. So I could make it 3x to the 5th. There's too many 5s in here. 3x, I don't know, to the 4th. That's such a big difference. Times x plus 5. Now, sometimes it does help to kind of write out the intermediate steps. This is kind of intimidating. So this whole thing gets multiplied by the x, and the whole thing gets multiplied by the 5. So if it helps, you can write 3x to the 4th times x plus 3x to the 4th times 5. Some people will go straight to the next step that we're going to write down, and that's okay. I'm just letting you know that, again, you don't lose points for using extra paper, so you might as well make sure you know what's going on. So this first term, we have 3x to the 4th times x, which hopefully at this point you've got down. There's a super secret 1 right there. So we could write it as x to the 4 plus 1. And then this next one is going to be 3x to the 4th times 5. So I multiply the 3 by the 5, get 15x to the 4th. And then I simplify 3x to the 5th plus 15x to the 4th. So if you skip any of these steps, a lot of times it'll be this step. A lot of times people will be able to go from here to here. Some people go from here to here. There's too many red arrows. Let me try this again. Some people will be able to go straight from here to this final answer. And the goal is eventually to get there if you're going to be doing a lot of algebra in your future. If this is the last algebra class you're ever going to need, then you're probably okay. But if you need to go from here to here to here to here, that's okay too. If you need to go from here to here to here, and you skip the third step or whatever step, the second step, that's okay too. Again, don't stress out about making sure that you're, you know, I don't know. Don't feel like you got to impress somebody with how quickly you did your math homework. Nobody cares. Just take the time and actually learn the material. So multiplying a polynomial by a single entity is usually not too bad. Where we start to get confused sometimes is if we're going to be multiplying it by, whatever you call those things, other polynomials. So kind of your classic, let's say I have x plus 3, and I'm going to multiply it by x plus 5. Now, a lot of you are already probably thinking FOIL method, and I'm cool with that, and I'm down with that, and I get it, but just let me do it my way for a second, and then we'll do the FOIL method, and then I'll show you why it was important that we did it this way to begin with. All right? So basically the idea, and it'll actually help you with factoring later. It's kind of why I'm being kind of the pain about it. But basically the idea is I want to multiply by the x by everything over here, and I want to multiply the 3 by everything over here, okay? So some people write it different ways. Some people will write, okay, they'll go x times x plus 5 plus 3 times x plus 5. And a lot of times that, if you try to do this, have done this, I don't know, this before, and it never seemed to work out, try writing it out like this and see if that helps. So you can still see the x plus 3, and each of those terms in the first thing is multiplied by each thing in the second thing. So if that helps, great. And now that I have it written like this, now the x gets distributed to each thing in its little partner, and the 3 gets distributed to each thing with its partner. So I have x times x plus x times 5 plus 3 times x plus 3 times 5. Okay? X times x, x squared, plus 5x, plus 3x, plus 15, and then again continuing to combine like terms, x squared plus 8x plus 15. Okay? Honestly, to me, that's the best way to do it. Some people will be able to go, again, from here straight to this step, but a lot of times writing out this step here is what kind of makes it go from, I've tried to do this before and it never made sense, to, oh, I finally get it now. So just consider that as you're going through. I know we want to get homework done fast, but at the same time, actually knowing what we're doing is helpful. So let's try another one. I'm going to do it a little bit funner. Let's say that it's x minus 2 and then x plus 7. All right, so again, the idea is you have this x that you need to multiply by everything, and you have a negative 2 that you need to multiply by everything. So I'm going to write x times the whole shebang, and then if you want to write plus and negative 2, go for it, times the whole shebang. So again, there's my x multiplied by everything, and there's my negative 2 multiplied by everything. Now that x gets distributed to each individual element, and the negative 2 gets distributed to each individual element. X times x plus x times 7 plus negative 2 times x plus negative 2 times 7. Okay. So I've got x squared plus 7x minus 2x. Negative 2 times 7 is negative 14. X squared minus 5x, plus 5x. X squared plus 5x minus 14. And we should be good to go there. Is that kind of starting to make sense? Now, again, for those of you who've done the FOIL method, you might be like, but I can FOIL anything. Well, you can and you can't. There's only specific things you can FOIL. I will show you the FOIL method if you've never heard of it before in a minute. But let's pretend that I had x minus 2 times x squared plus 2x plus 5. Now, all of a sudden, this isn't something that you can FOIL anymore, okay? But it's the same process. I've got the x that I want to multiply by everything, and I've got the negative 2 that I want to multiply by everything. So I've got x is going to get multiplied by x squared plus 2x plus 5, and the negative 2 that's going to get multiplied by x squared plus 2x plus 5. Okay, it's all about the process. So x times all that stuff, negative 2 times all that stuff. X times each element that it's paired up with, negative 2 times each element in that expression that it's paired up with. And again, don't be a hero. X times x squared plus x times 2x plus x times 5. So don't be afraid to write out all the steps. Plus negative 2 times x squared plus negative 2 times 2x plus negative 2, you can't see what I'm writing anymore, times 5. Okay? Now we just continue to simplify. Why am I doing this? Just so you know, a lot of what you're doing with all this math stuff, it's all about learning deductions, learning organization, learning process, learning problem solving, following an established route, following logic. So x times 2x is going to be 2x squared. For me, I do this because I love it. There's something so satisfying about doing all this. It just gives me joy. I like the way the pencil feels on the paper. So negative 4x minus 10. Now combining like terms, so the x cubed is the only x cubed. Now I've got to find all of my x squared terms. There's an x squared term, and there's an x squared term. And something interesting has happened. I actually have a 2x squared minus a 2x squared, which actually means that the 2x squareds are going to go away. Now, if you want to remember that for later, like if you're checking your notes, you can go ahead and write 0x squared. Then I have a 5x minus 4x, which will be just an x by itself. And then the minus 10 is the only one that's left. If you want to go ahead and take out that 0x squared before you finally box in your answer, that would be the thing to do. Okay, so something along those lines. Kind of seeing how that's going. Now the FOIL method, so this method here works all the time for everything, okay? no matter what you've got, this method will work. If you just take each term and multiply by each successive term in that expression, you're wonderful. Now, a lot of people, however, were raised on the FOIL method. And FOIL stands for first, outer, inner, last. So first, outer, inner, last, which basically means that you take the first two terms, I'm not going to do it that way, the first two terms and multiply them together. Then you take the outer terms, that's not what I meant, the inner term, the outer terms, those are the outside terms, and multiply them together. The inner terms and multiply them together. And then the last terms and multiply them together. So for a lot of people, that makes just as much sense as anything else. So we've got our first, our outer, our inner, and our last. So first would be x times x, and then the outer would be x times 9, and the inner would be 5 times x, and then the last would be 5 times 9. 5 times 9. Did it? 5 times 9. Be 5 times 9. So we've got x squared plus 9x plus 5x plus 45. And again, combining those like terms in the middle, x squared plus 14x plus 45. So the FOIL method is great, but it only works if you have a polynomial with two terms and another polynomial with two terms. If I have this, now all of a sudden you're like, well, where's my outer and where's my inner? So you don't really have an outer and an inner, so it doesn't matter, which is why you have to go back up to solving a problem this way. Good? Woot. Let's do some practice. Okay, so here are some good problems to practice with, just to make sure you kind of understand what we've done in the video. So my recommendation is that you now pause the video and see if you can get anywhere with these. And even if you can't, when you rewatch the video or if you unpause the video, go ahead and watch a couple of steps and be like, okay, I think I could take it from here, and then repause it and then try again. So again, pause the video, see how far you can get. All right, so let's assume you've done that. Okay, so I've got each one of these terms here. The x wants to be multiplied by everything over here, and the -3 wants to be multiplied by everything over here. Okay, and just so you know, we haven't really talked about this, and I'm not going to make you do even more, but let's pretend I had like even more of these. Then it would just be like, well, the x squared wants to be multiplied by everybody, the x wants to be multiplied by everybody, and the 3 wants to be multiplied by everybody. So instead of doing this 2 times, you do it 3 times, okay? So it's just a pain to have to do, and it takes forever, so we're not going to do that today. But in any case, first I have the x multiplied by everything here, and then the -3 multiplied by everything here. So we've got the -3 and the x. And this goes to toop, to toop, to toop. And this goes to toop, to toop, to toop. All right. So I have x times 3x squared plus x times 2x plus x times 1. And then -3 times 3x squared, -3 times 2x, and you still can't see what I'm doing. And then -3 times 1. So 3x times 3x squared, remember there's that secret 1, so I have 1 plus 2 is going to give me x cubed times, or plus 2x squared plus x minus 9x squared minus 6x and minus 3. Now, the thing that's going to get us most of the time, if it's not the initial steps of doing the distribution correctly, it's going to come down to simplifying it incorrectly, and I'm really, really good at simplifying things incorrectly. So that's why you'll see me make these little marks. I'm like, okay, so there's my x cubed. That's the only one like it. 3x cubed. All right, then I have 2x squared minus 9x squared. So 2 minus 9 is -7. negative 7x squared. All right, then I've got the x minus 6x, so remember that's a 1. 1 minus 6 is going to be negative 5x, and then that little negative 3 on the end. Okay, so if you got all the way through that problem, congratulations, that was kind of legit. It's a legit start. Not terribly less legit than this one, though. This one coming up is also super duper fun. Okay, so again, the idea is I mean, this is intimidating because it seems like it's a lot, but it's really just doing the same thing. So that 5x gets multiplied by everything there, and the negative 1 gets multiplied by everything there. So 5x times that negative 2x cubed plus 5x squared minus 2x plus 7. And then minus 1, or I'm going to write plus a negative 1 times negative 2x cubed plus 5x squared minus 2x plus 7. And again, this whole thing is going to get multiplied by each thing here, and the negative 1 is going to get multiplied by each thing here. All right, 5x. And honestly, who cares how many pages it takes you to do this? So if you need to go ahead and kind of 5x times this, 5x times this, 5x times the next thing, 5x times the next thing, good. And then negative 1 times the first thing, derpsh, derpsh, derpsh. Negative 1 times the first thing, negative 1 times the second thing, negative 1 times the third thing, and negative 1 times the last thing. Whew, that's exhausting. Don't give up. You gotta want it. Like, but I kind of don't want it. Want it anyway. It's easier if you pretend you want it. All right. So I've got 5x times negative 2x cubed. All right, so it's 5 times negative 2 is negative 10. That's x to the first times x cubed, so that's x to the fourth. All right, done. Next term, 5 times 5 is 25. X times x squared is x cubed. 5 times negative 2 is negative 10. X times x is x squared. 5 times 7 is 35. X. Okay. Now, because I've solved these problems before and I kind of know what's going to happen, I'm going to organize these in a way that makes it a little bit easier to see. You might not have been able to organize it the first time that you did it, but you could always recopy it and organize it this way. After you write the first messy line, you could recopy basically the same thing, but just kind of organize it a little bit better to make it easier to see. So that's what I'm going to do now, but I'm going to do it the first time. Negative 1 and negative 2 is positive 2x cubed. Negative 1 and 5 is minus 5x squared. Negative 1 and negative 2 is positive 2x. Negative 1 times positive 7 is negative 7. So as you can see, I've kind of lined these up where the x to the fourth doesn't have a partner, but the x cubes are lined up, the x squareds are lined up, and the x's are lined up. This is just another thing you can do to kind of help keep your work organized. So I have 10x to the fourth, 27x cubed, negative 10 minus 5, it's going to be negative 15. 35 and 2 is 37, and negative 7, and you're done with that. Woohoo! All right, last one. I'm going to go ahead and use the FOIL method because I imagine a lot of y'all did, and we've already solved it the other way for those previous two examples. So we have first, outer, inner, and last. That was last, inner, outer, first. First, outer, inner, last. So the first two together, do another different color. So the first two together, I have x times 3x to the fifth, and then I have outer, which is x times a negative 2. Don't lose that negative. And then I have inner, which is going to be 7 times 3x to the fifth. And then I'm going to have last, which is 7 times negative 2. So that's 3x to the 6th, because that's x to the 1st times x to the 5th, 3x to the 6th, minus 2x, plus 21x to the 5th, minus 14. And then just to be polite, we reorganize everything in descending order based on the power of those exponents. And we're good to go.